Welcome to the SPP course. First, let me briefly explain what SPP means. SPP stands for Scan, Plan, and Print. This course covers the key elements of digital dentistry. We will talk about CBCT scanners, intraoral scanners, and facial scanners. We will also cover surgical guide fabrication, digital treatment planning with R2 gate, and 3D printing for prosthetic restorations. The SPP course is divided into two parts. The first part is the online course. In the online sessions, we will explain the overall digital workflow and core concepts. The second part is the offline course. During the offline course, you will experience hands-on training. You will plan cases, design restorations, and print your own results. We invite you to visit the MegaGen America office, because in digital dentistry, hands-on experience is the best way to learn. Today's first online session focuses on an immediate loading case. We will review how to plan the case in advance, prepare the prosthesis before surgery, and deliver it immediately after the procedure. Now, let's start. Let me walk you through this case. An implant was placed immediately after extraction, and the provisional prosthesis was delivered on the same day. In the planning software, I can perform a virtual extraction. After that, a virtual wax-up can be created. Based on this design, the crown can be 3D printed and prepared before surgery. For the final prosthesis, the expertise of a lab technician is still essential. However, a provisional restoration can be prepared much more easily. I want to show you how simple and efficient this process can be. For this case, I used the MegaGen Blue Diamond implant. The implant size was 4.4 by 10 millimeters. During the planning stage, a virtual scan body can be positioned according to the implant location. Because of this, the custom abutment can be designed before surgery. This allows us to prepare the prosthetic components in advance. I delivered the custom abutment and the 3D printed crown. After delivery, I took an X-ray. The custom abutment was fabricated through the R2 milling center. The crown shade was not a perfect match. However, the fit was very precise. I did not need to adjust the contact or the bite. For the treatment plan, when the patient first visited my office, I took a CBCT scan to obtain the DICOM data. I also performed an intraoral scan to get the STL file. After that, I scheduled the surgery date. Using R2 Gate, the planning software from MegaGen Implant, I completed the digital planning and designed the surgical guide. Based on the previously created diagnostic wax-up, I designed the provisional crown and the custom abutment. Using a TI base or a stock abutment would also be a good option. I 3D printed the crown and the surgical guide in advance. Immediately after surgery, I delivered the pre-prepared prosthesis. The patient was very satisfied with the result. On the patient's first visit, I performed a CBCT scan after the consultation. If you are using a small FOV CBCT machine, the sinus area must be included in the scan for maxillary cases. For a mandibular case, the mandibular nerve must be included. This is essential for safe and accurate treatment planning. Of course, if a sufficiently large FOV is available, it is recommended to include all relevant anatomical areas in the CBCT scan. After that, I performed an intraoral scan. For this case, I used the MegaGen R2 i3 intraoral scanner. I completed the scan of the surgical area. I also scanned the opposing dentition. This allowed me to capture all the necessary data for planning and prosthetic design. The MegaGen R2i3 scanner has a feature that allows patients to review their oral condition on their phone after the scan. This makes consultation more effective and easier to understand. Patients can also go home and discuss the treatment plan with their family. I imported the intraoral scan data into the R2 Gate software. In this area, I performed a virtual extraction as part of the planning process. I selected the area where I wanted to perform the extraction. This is the result after the virtual extraction. At this stage, it is important not to remove the contact area of the adjacent teeth. If the contact is deleted, the space will become larger than the actual clinical situation. I created a diagnostic wax-up in the extraction site. By selecting the tooth, I was able to generate it, move it into position, and adjust the size as needed. Because I plan the prosthesis first and then proceed with treatment, this approach is called top-down treatment planning. I imported the DICOM file into the software. This software has a feature that reorganizes the value range based on Hounsfield units. It also includes a function called Digital Eye, which displays this information in color for easier visualization. After the reorganization process, I was able to review the DICOM data in a clean and clearly aligned format. I imported the intraoral scan STL data. Then, I performed the superimposition onto the CBCT data using a three-point alignment method. After merging the two datasets, I verified the alignment using a color map. Even if the data is merged automatically, it is very important to verify the alignment manually. Soft tissue appears slightly gray, and air appears black. Using these visual differences helps you adjust and confirm the alignment more accurately. The brown outline represents the STL data. I made a slight adjustment because additional alignment was needed. This step is important to achieve a predictable surgical result. Scattering can occur around prosthetic materials, so it is important to use natural teeth as reference points whenever possible. Another effective method is to use radiopaque materials, such as flow resin, to improve alignment accuracy. Since this is a mandibular case, I traced the mandibular nerve. If the nerve is not clearly visible, using the digital eye function can also be a useful option. If the nerve is not clearly visible on the CBCT, it is safer to mark it slightly larger than expected. This helps increase safety during surgery. After tracing the nerve, it is displayed like this on the CBCT data. If the fixture is positioned too close to the nerve, a warning message will appear. This helps prevent potential problems during surgery. Now, this is the step where I determine the ideal implant position. Using the digital eye feature I mentioned earlier, I can evaluate bone density in color. This allows me to identify the best position for achieving good primary stability. There is also a measure function. This is an important tool that allows me to measure the distance between the residual root, adjacent implants, and the nerve. I can also measure the distance between the final prosthetic contact point and the bone crest. This helps me predict the possibility of a black triangle. From the menu, I can select the implant system, including the diameter and length. I can also choose the healing abutment or a stock abutment to check the required size in advance and prepare it before surgery. I also selected a scan abutment. This is because I planned to design a custom abutment later in exocad. Now I will move on to the surgical guide design stage. If you have used R2 Gate before, you may notice that this design process looks different. The previous method is still available. However, today I will show you a new approach that can be used free of charge. MegaGen surgical guides are designed as a non-sleeve type, which means they do not require a metal sleeve by default. However, if you prefer to use a metal sleeve, the guide can also be fabricated as a metal sleeve type. In contrast, other software programs, such as Implant Studio or Blue Sky Plan, generally require the use of metal sleeves as a standard. When using a surgical guide, overheating can occur during drilling. Because of this, proper irrigation is very important. To help with irrigation, there is an option to create up to 4 windows in the surgical guide. For this case, I used the MegaGen Blue Diamond Guided Surgical Kit. The height offset for the MegaGen kit is 12.5 millimeters. If you want to use a different implant system and a surgical kit from another company, you can manually enter the offset value. You can obtain this offset information directly from the implant company. Let me explain what offset means. Offset is the distance from the top of the implant fixture to the stopper position of the drill. In other words, it is the distance from the fixture platform to the point where the drill stops inside the surgical guide. For the MegaGen implant system, the offset is 12.5 millimeters. To design the guide, I set the boundary. Since the undercuts have already been blocked out, there is no problem including the interproximal areas. After completing the planning, I can export a report. The report also provides a drilling sequence based on bone density. Reviewing this report is very important before surgery. To 3D print the surgical guide, I imported the completed guide STL file into the printing software. I positioned the surgical guide so that the outer surface faces the build platform, not the inner surface. Now everything is ready for printing. I can check how much resin will be used and how much time the print will take. Since 3D printing time is determined by the height of the object, multiple items can be printed at the same time without increasing the total printing time. That is why having a larger build platform is very important for efficiency. The information is automatically transferred to the 3D printer. Then, the printing process begins. The resin tank is filled with shining 3D surgical guide resin. The build plate moves down, and the object is created layer by layer. Each time the light is exposed, the resin is cured and one layer is formed on the build plate. Because the object is built layer by layer, the 3D printing software is often called a slicer. After printing is complete, the guide finishes in this inverted position. For this case, the printing time was about 25 minutes. The next step is washing. I move the build plate to the washer unit. This is a convenient unit that performs automatic cutting and cleaning. One advantage of this washer unit is that it can automatically separate the object from the build plate. This means I do not need to remove it manually. It helps keep the working environment clean. The separated object is placed in a basket and submerged in 99% isopropyl alcohol. This process removes any remaining resin from the surface. After washing is complete, I remove the surgical guide from the basket. The guide is still covered with alcohol, so it must be dried thoroughly. In the curing unit, I select the surgical guide setting from the menu. Then, I proceed with curing for the recommended amount of time. There is one important step to prevent the drill from binding during surgery. I use a hole trimmer to refine the drill hole. Different hole trimmers are available for each size. I trim the hole from bottom to top and then from top to bottom. About 5 rotations are usually sufficient. The second tool is the stopper trimmer. This tool helps the drill stopper seat properly into the guide stopper. I insert the stopper trimmer into the drill hole and trim the stopper area by rotating it about 5 times. You will be able to see material being trimmed away. There is no need to overdo it. A light trim with about 5 rotations is enough. This scan data was created using virtual extraction. Since only the teeth were deleted, the gingival contour was not reproduced. In the CAD software, I could press the data to form the gingival contour. Normally, scan body data is acquired after the implant is placed. But because the fixture position is already known, we can extract it in advance. For custom abutment design, the Blue Diamond library was matched to the scan body. Here's a useful tip. If you adjust the scan body matching area, the matching accuracy will improve. Since the prosthetic space was considered in advance, the outcome is more functional and more aesthetic. Adjust the abutment shape while considering the crown form and the opposing teeth. This helps create a uniform thickness. I completed the crown design. Then I imported the design file into the printer software for 3D printing. I will also show you how to use MegaGen as a TI base and EasyPost as a stock abutment. I extracted the stock abutment from the planning software. With a one-point click at the margin area, the margin line was created. I applied the diagnostic wax-up as it was and completed the design right away. This is the extracted T-base. In the same way, I created the margin line with a single click at the margin. As you can see, the diagnostic wax-up was applied directly. This means the crown was completed without an additional design step. You may have experienced restorations that feel too tight or too loose. In CAD software, the tolerance can be adjusted. A smaller value creates a tighter fit, while a larger value creates a looser fit. By controlling this value, you can achieve the desired fit. I imported 2 versions in total. One has a screw hole and the other does not. I used the auto-arrange function for the crown and the supports were automatically generated under optimal conditions. I printed the crown using a small size build plate. The reason I use a small resin tank and a small build plate is cost efficiency. Crown resins are more expensive than other types of resin. Although I used temporary crown resin in this case, ceramic-filled crown resins are even more expensive. Each resin tank requires a minimum amount of resin. With a small resin tank, only a small amount is needed to reach that minimum level. However, a regular-sized tank requires a much larger volume of resin. That is why I use a small resin tank and a small build plate. The printing is complete. After removing the crowns from the build plate, I followed the same cleaning process used for the surgical guide stent. Since the implant diagnosis, planning, surgical guide, and crown were completed, I proceeded with the surgery. The tooth was extracted first. I reviewed the report beforehand. Still, during surgery, it is a good idea to keep it next to you so you can check it any time. One important point when using a surgical guide stent is this. First, position the drill inside the hole. Then, start the rotation and move it up and down. This is important for stable and safe drilling. I took the MegaGen Blue Diamond implant out of the package. One of the key features of the MegaGen Blue Diamond implant is the X-bead treated surface. This treatment gives the implant its distinctive blue color. I attached the smart peg to the fixture and measured the ISQ. The value was above 70, confirming that the implant was suitable for immediate loading. After fixture placement, I took an X-ray to confirm the position. I used the R2 milling center to prepare the custom abutment, and the result was milled very well. The R2 milling center is based in New Jersey. After scanning with an intraoral scanner, you can simply send the data. They take care of both the design and milling. I connected the custom abutment to the fixture. I completed the crown delivery. In this case, I did not apply stain or glazing. However, for anterior crowns, adding stain and glazing can achieve a quality that looks like a final restoration. In the SPP offline course, there is a hands-on session where you can directly practice staining and glazing on 3D printed crowns. Did you clearly understand the full workflow for immediate loading, from CBCT scanning to printing? If you have any questions or inquiries, please leave a comment or send me an email. If you would like to attend the SPP offline course and participate in the hands-on session, please register through the MindTech website. The next session will be a hands-on session where you can perform this workflow yourself. Listening to a lecture alone is not enough to apply it to your practice. I will help you apply what you learned and grow through real hands-on experience.